Cotina. Today I'm going to talk about genetic network and breeding pattern of sicklefin lemon shark population in Society Island, French Polynesia. In the beginning, we will talk about introduction. What is sicklefin lemon shark? This is one of the species of lemon shark, and it lives in less than 92 meter depth tropical ocean of Indo-Pacific. Indo-Pacific including Indian Ocean and Western and Central Pacific Ocean. And you can find it in mangrove and coral reef. And it has cell body and two dolphins like in here, 1 and 2. It can go up to 3.4 meter long. And I'm sorry that my video didn't work, so I can use my body language. Just they have violent mating behavior. Male shark will bite female shark and to control their position of female shark. So we will observe the scar on the female shark to know if their mating activity. And this video is not working too. And this viviparous, this word is mean the baby is developed inside the body of female like human or mammal, it's not in the egg. So human pressure has put many types of predators and population at the risk of extinction, including shark, due to their case selection, like slow growth or long lifespan. So this IUCN red list, this has put many threatened species in this list, and lemon shark is put in vulnerable, and that means they are likely to become endangered. Maybe it will just disappear. So our aim is to investigate the genetic makeup and mating output with the small isolated shark population, and to know how they keep their maintain their population and gene variability. In the method, this study was methodically conducted in Mourier, but we also take some sample in Bora Bora and Tetiaroa, and that's because some shark in Mourier it will go to those two places. And those two prey sharks will go to more like a dispersal, and I will talk to it later. So we use underwater observation. The photo identification will report the scar on the female shark as a sign of their activity, mating activity. Like this picture in 2008. This is a female shark, and this is her scar. And we also use microsatellite genotyping. Microsatellites are the standard marker of identity by DNA profiling. We will arrange and compare the DNA to see if they have same DNA or they have different DNA. And microsatellite can let us to analyze gene sequence. So we get 18 shark to see if they have gene deficiency. And after we get their DNA, we will use this system to find their mother offspring and father offspring. And this system is called PLoS, and it's a computer program that assignment of parents their offspring using genetic marker. And so we just put the DNA data into this system, so it can help us to find parents offspring and sibship. So after we know their DNA, we can make a relationship construction between individual pairs. Like PLoS means parent offspring, FS means full sibling, HS means half sibling, U means unrelated. So in the result, in the microsatellite we can find significant gene deficiency, and in genetic structure the mean coefficient of adult relatedness is low. But all individuals are interconnected, and this by one first-order genetic relationship. And this page you can want to tell you that all the sharks have a little blood relationship, but not very close. And this is a figure about reproductive behavior of those lemon sharks. And at first I will talk about females. And vertical line is mean female, and horizontal is mean ears, and white squares mean male shark, and colored squares mean baby shark, and different color is from different place. And I make an easier figure to show you that the vertical is female and horizontal is mean ears. So you can see that two female will return to the same nursery in 2 year cycle, like this 4 female. And 2 will return to the same nursery in consecutive year cycles. And the reproductive behavior of male, 10 of the 20 fathers sire more than 1 litter. And litter in here means a group of animals that are born at the same time have same mother. And 5 male met with multiple female in single year, like this figure. You can see in 2006, male 9 it met with 2 female, and in 2007, and male 4 it met with 2 female. 2006 it met with 3 female, and 2009 both 3 and 2 it met with 2 female. So our discussion is we find dispersal are very important to make their population and genes, because during each breeding period, most resident male will disappear from death to weak, and non-resident will show that in Mourier. And the immature shark can dispersal from birth location or change their nursery locations to make sure their genes. And I will talk later. The reproductive behavior, the female may follow an average 2 year reproductive cycle and did not immediately pregnant, like this figure. For example, the female 13 is pregnant in 2007, but in 2008 it did not immediately pregnant. It pregnant in 2009. And polyandry played a major role in reproductive behavior. That you can see the female as it met with 3 male sharks in 2006. And male almost never met with female shark every year. Like for example, the male 10. You can see male 10 it met in 2005 and 2006. But in 2007 to 2009, you won't see the male 10 in these figures. So in a genetic diversity, you can see this figure. The vertical is mean internal relatedness, and the horizontal is mean maturity status. And you can see juvenile has higher IR than the matures. But when juvenile grow up, it will go decrease. That's because the juvenile with higher IR will migrating away from their natal site. And juvenile with higher genetic diversity have higher survival rates than the lower genetic diversity. The higher genetic diversity is mean they have lower IR, and lower genetic diversity is mean it have higher IR. So the shark want to keep their populations and gene variability. So the juvenile with higher IR it will go dead or by natural selection, or it will go to another place to make sure the mature he have higher survival rate and can maintain their populations. So in this conclusion, the isolated island system has encouraged the sicklefin lemon shark to develop different strategies to avoid inbreeding by dispersal and reproductive behavior. And that's because you can see, I just told now, dispersal and reproductive behavior can make their genes have more variation. So if the juvenile with higher gene diversity, and when they grow up, they may have a child. So their child can have the higher gene that then they have more lower IR, so they can have a longer life and can continue to maintain their population. So that's all my report. Thanks for listening.
Roy. Kevin Chen. Ian. Alex.
What does IR mean?
This is intermal related. This is mean that DNA is close or it is it has genetic diversity or it has a low genetic diversity.
High IR means high or low genetic diversity. Again. High IR value means higher genetic diversity or lower
Low genetic diversity.
Okay. Right.
Can you explain dispersal again?
You mean this page?
Yes.
During the mating season, the resident shark will go to another place, and the non-resident will show up, so they can keep their gene diversity. And the immature shark will go to another place or change their nursery location to make sure their population is maintained in this balance.
Kevin Chen.
Yeah. To the red dot, next page. Yes. What is polyandry play a major role? What is polyandry?
You mean it's more?
Yeah.
That means a female has more than one husband. They maybe have two mating with two sharks, male sharks.
Yeah.
How did you get a shark DNA?
We use a special spear gun to catch their DNA, and this spear gun with a biopsy tip to cut a little bit their fin to get their DNA.
Volunteer question. Andy. One. Okay. Two. Sorry, I forgot again. Okay, right.
The lemon shark population is truly decreased. They investigate the population of lemon shark.
Could you speak again?
Did they investigate the lemon shark population? Did they truly decrease?
It did not mention in this paper, but in our study press, the lemon shark it did not have pressure by humans. So this is when lemon shark is maintain their population. So in this press, we can see that.
Why do you choose Mourier to do your study?
Oh, because this press it has not experienced the human pressure like overfishing. So and those sharks have been protected by law in 2006. So in this press we can see the natural ecosystem.
Okay. So her talk was quite easy to follow because her slides were well made, and she also talked, perfectly speak. But I think there are several points that can be improved. So in your slides, there are many terms that need to be further explained. Here is a good example, like polyandry. then you explain during the QA, but it can be explained when you say it. And I also wrote down many of the terms, like what is sibship, what is gene deficiency, what is full and half-sibling. So these terms, as long as it takes you to think a bit, then you can explain it in easier words. Okay. And then I also had the same comments that the results, the IR, here, the IR can be explained when you first time you say it. Because when you have this, I thought this is the definition of IR, you know? So, but this is actually the conclusion. So it's better that you explain first what does IR mean. And also, like one of the questions, you also need to explain after your study site, how did you get the shark's DNA? And then, considering that your talk speed was not particularly fast, but you did not make enough time, so I would say you can. I would say there are some photos that you can add. I know you prepare some videos, which might easily makes you 10 minutes. So next time, make sure you use WMV format. I have said that at least 3 times. So, or you add these nice photos, like you see this shark with big belly. Okay, this one. This shark, D. You can use the photos, and I'm also wondering if this will give you if this can provide a strong impression to the audience if you present shortly this figure. This figure. Do you understand it roughly? It's actually thicker lines that are more closely related. Because at some point you say the population, the individual in the population was more or less connected. And this graph is scientific evidence showing you the extent of connectedness. So you can show this, but you don't need to explain too much detail. Okay. And then another thing about your talk is because here start from this slide, you talk about discussion, and I think I like the following part of your discussion because you have tried to simplify and help us to understand this important table. But regarding the dispersal behavior, it looks like you have not mentioned this. You know, part of these are observations. So I would say some of the statements here should be observations, should be results. So you put them to results. And then here, you focus on how this dispersal behavior affects their genetic diversity. Like it plays a part in improving the genetic diversity. So that's the focus of the discussion. Okay, so try to separate results and discussion. But overall, I think it's a good talk. So let's thank Cotina. Based on the clock, 6 after 11.
上礼拜有做，然后我觉得这一种真的没有比早一点好，这一种然后就很压抑，大家。
记得有没有？
我连10种都在记别人讲，我就不太喜欢，完全跟反省自己的光是。对啊，
带我。
下一首大家还需要问题吗？
break, lunch.